Here we have shown how from a set of equations we can create the augmented matrix and few other matrix related terms. Okay, so you can see there's three equations: 2x plus 5y plus 3z equal to 16 minus x plus 11z blah blah blah, all this. But when we are creating the augmented matrix, we have to remember that the 6y is in this side. You have to bring it in this side and place under the column of y. Okay, so for x there will be a column, for y there will be a column, for z there will be a column, and all the constants on the right side will be also aligned. So if there is some variable not present, like here you see there is no z, so instead of z we have to put a 0 times z, that means the coefficient will be 0. So then we align them in such a way, you see 2, 5, 3, and then 16 is the constant, minus 1, minus 6 when it comes to this side, and 11, and then minus 7 is the constant, and 3, minus 9, and there is no z, so it's 0, and then 11. So this is the augmented matrix from the set of linear equations. Okay, this will be necessary to solve the equation. So one thing I would like to tell you that all the equations, the examples I'm taking in the board are basically, I have not checked them, they are possible to solve or not. These are just some examples I'm randomly taking. So do not, if they are not solvable, do not worry about that. So there is another way of writing this. Okay, I want to show you that also here. So here you see I am taking the variable out and writing 2, minus 1, and 3 as a column vector or as a column matrix. Okay, and then plus y. So it's a linear combination like we have seen in the vector equations. So plus y times 5 minus 6. So it's very similar to this, the column matrix, along with that the variable y and then the variable z, and the similar way. Okay, so now we have created the coefficient matrix here, like we have shown earlier, coefficient matrix, and we have said the three variables are x, y, z. You see, the three variables are x, y, z, and this side is the constants. Okay, so now you see this is basically the same thing as this equation. How it works, it follows the rule of matrix multiplication. Okay, so matrix multiplication says that 2, 5, 3, 2 times x, so you go this way in the row, and then here you go the column, 2 times x plus 5 times y plus 3 times z. You see exactly equal to 16. Okay, so it's a matrix multiplication. This is the 3 by 3 square matrix, and this is a column vector which are just the variables. So 2 times x plus, similarly, minus 1 times x plus minus 6 times y plus 11 times z, and 3 times x minus 9 times y, 0 times z equal to 11. Okay, similar way. So this coefficient matrix, these are the variables, and these are the constants. And also see this can be represented as this format. This is a very standard form of representing linear equation in the matrix form. A x equal to b, where a is the coefficient matrix, x is the vector, and b is the set of the constants. Okay, so ax equal to b. We'll come back to this later. Also, a few other things I want to tell you. What is a square matrix? A square matrix is a matrix with a, in the form, the rows and columns are same in number. So like this is a 3 by 3 square matrix. We call it a 3 by 3. There can be a 2 by 2. There can be a 4 by 4. Okay. So what is a diagonal or identity matrix? So we have to tell you that this is considered the principal diagonal of a matrix. Okay. So here you see, for the diagonal identity matrix is this one, where there will be only diagonal elements in the matrix, and the identity matrix, if the coefficient matrix looks like this, we call it identity matrix, and there are only 1, 1, 1 in the diagonal, and all other elements are 0. So it's the upper triangular matrix, which is for square matrix, if the the below the principal diagonal all the elements are 0, we call it an upper triangular matrix. Similarly, the lower triangular matrix, the matrix where all the elements above the principal diagonal are 0.